Hi, I'm Syed on Maths Online. Today I'll be taking up one problem based on applications of differential equation. In an LCR circuit, the charge Q on a plate of a condenser is given by this differential equation. The circuit is tuned in resonance so that P square is equals to 1 by LC. If initially the current I and the charge Q be 0, show that for small values of R by L, the current in the circuit at a time t is given by Et by 2L into sine of Pt. So let's start this solution by writing the differential equation. So the given differential equation is L times of d square Q by dt square plus R times of dq by dt plus q by c is equals to, it is E times of sine of pt. So let us write down this in the form of the operator. L times of d square q plus R times of d times of q plus q by c is equals to E sine pt. So let us take q common outside here. L times of d square plus R d plus 1 by c times of q is equals to E sine pt. Let us write down the auxiliary equation. So the auxiliary equation is L m square plus R times of m plus 1 by c is equals to 0. This equation is of the form ax square plus bx plus c is equals to 0. And the root of this quadratic equation is given as x is equals to minus of b plus r minus square root of b square minus of 4ac divided by 2 times of a. Now if you try to compare the values over here, the value of a will be, here x represents your m value. So coefficient of this x square, that is coefficient of m square, will be L. So a value will be L. So here coefficient of m represents your b value. So b value will be R. And the constant term c is equals to 1 by c. Therefore, we get m to be equals to this formula, minus of b. So b value is r. So plus r minus, that is square root of b square. So b square will be r square minus 4 times of a into c. That is a into c. L into 1 by c. Its whole divided by 2 times of a. So a value will be L. Now let us try to divide each of the term by 2L. So you have minus R by 2L plus R minus root of R square minus 4 times of L by C whole divided by 2L. Now if I want to take this value of 2L inside, I can rewrite that as, so this term minus R by 2L as it is plus R minus, this is square root of R square minus, this is 4L by C whole divided by. So when this 2L comes inside this square root, it becomes 4L square. So because it is under the root, so under root 4L square will give back the value 2 times of L. So the 2L which comes inside the square root will become 4L square. Now let us try to divide each of the term by 4L square. So which will be equals to minus R by 2L plus R minus, it is square root of R square by 4 times of L square minus this 4L divided by C. You can take this C in the denominator. It becomes 4L square C. So you can just cancel out this 4 and you can cancel out one L value. And further, it is given in the question that the value of R by L is small. So it is given in the question here. You can read, show that for small values of R by L the current is so much. So you have to show for R by L the current value, and R by L is small. So since R by L is small, so R square by L square under the root will become small. So hence this R square by L square becomes a smaller value. Therefore we'll try to ignore this one. So since R by L is small, we'll try to ignore the value of R square by 4 times of L square. So we'll just try to ignore that one. So this entire R square by 4L square will cancel out. So there is R square by L square or R square by 4L square. The whole term will be ignored. So you can write M to be equals to minus R by 2L plus R minus. Since we have ignored this value, so we will be left out only with minus of 1 by L times of C. But if you try to see the question, in the question it is given that P square is nothing but 1 by LC. So in place of this 1 by LC, I can replace the value as P square. But given the value of P square is equals to 1 by LC. So if I put that value back over here, it is M is equals to minus R by 2L plus R minus, it is square root of minus of 1 by LC value will be P square. So this will be equals to minus R by 2L plus R minus. Root of negative value will be I, and square root of P square will be P. So we got the value of M to be equals to minus R by 2L plus R minus I times of P. So let us write down the complementary function. So the complementary function will be, since it is a complex roots, we'll get e power of. So it is minus R by 2L times of T into, it is C1 cos of P times of T plus C2 sin of P times of T. So that's the complementary function. Now let us try to find out the particular integral. So particular integral will be 1 by the operator L d square plus RD plus 1 by C times of, right hand side of the differential equation is E sin PT. So this given expression is of the form 1 by f of d square times of sin of ax. So whenever you want to find out the particular integral of this form, you have to replace the value of d square by minus of a square. So you will be getting 1 by f of d square will be replaced by minus of a square times of, it is sin of ax. If you use this particular integral form, so I have to replace the value of d square by this coefficient of t, that is minus of p square. However, this e is a constant, so I will keep this e outside here and replace d square by minus of p square. Replace d square by minus of p square. So we will be getting L times of d square is being replaced by minus of p square plus R times of d plus 1 by C times of, you have sin of PT, which will be equals to, it is E divided by, it is minus L times of P square plus R times of D plus 1 by C into, it is sin of PT. But the value of P square is 1 by LC. So if you try to plug in over here, we'll be getting E divided by minus L, and the value of P square is 1 by LC plus R times of D plus 1 by C times of sin of PT. So here this L and L will cancel out, will be left out with minus 1 by C. So here you have minus 1 by C plus 1 by C. It will cancel out, you will just be left out with E divided by RD into, this is sine of PT. But 1 by D represents integration, so E by R, it is integral of sine of PT into dt. So this will be nothing but E by R, and integration of sine will be minus cos PT divided by the coefficient of t, which is P. So this will be its integration. So this can be written as minus E by P times of R into, it is cos of PT. So we have got the particular integral. So let's write down the solution. The solution is Q is equals to CF plus PI. So the value of Q will be equals to, CF is e power of minus R by 2L times of T into, it is C1 cos of PT plus C2 sine of PT. Particular integral value will be minus E by PR into, it is cos of PT. Since this is in terms of an exponent, we have the formula for e power of x to be equals to 1 plus x square by 2 factorial plus so on. Now here in this case, the value of x is minus R by 2L times of t. So if you try to replace over here, you have e power of minus R by 2L times of t will be equals to 1 plus x value is minus R by 2L times of t plus, here x square value will be minus R by 2L times of t whole square divided by 2 factorial and so on. So this can be written as 1 plus into minus will be minus R by 2L times of t plus, if you try to square it, it becomes R square by 4 times of L square. So this becomes 4. So 4 times of 2 will become 8. 2 factorial is 2. So this is 4 times of 2 will be 8. And this becomes L square into, this is t square. And so on. But since we know that the value of R by L is small, since R by L is small, we'll try to ignore R square by 8 L square and its higher order terms. So R square by 8 L square T square is ignored. So now this becomes e power of minus R by 2L times of T is equals to 1 minus R by 2L times of T. All these higher order terms are ignored. Now if you try to plug in this value back in Q, so the value of Q will be equals to, so e power will become 1 minus R by 2L times of T into, you have C1 cos of PT plus C2 sine of PT minus, it is E by PR into cos of PT. So that's the value of Q. So let us take this as equation number 1. So it is given in the question that Q is equals to 0 initially. That means when time t is equals to 0, Q is equals to 0. So if you try to plug in this values over here, Q value is 0 over here. It is 1 minus t value is 0. So this term becomes 0. Into, you have C1 cos of t value is 0 plus C2 sine of t value will be 0 minus, it is E by P times of R into cos of 0. You know the sine 0 will be 0, whereas this cos 0 value will be 1. So cos 0 is 1. So this is 0. So cos 0 is 1, you just have C1. So 1 times of C1 will be C1 over here. Further here, this term is 0. So this term over here is minus E by P times of R. So if I take this negative sign on the left hand side, it becomes positive. Therefore, the value of C1 will be E by P times of R. So we got the first constant value, C1 value. Now to find out the value of C2, this value of Q has to be differentiated with respect to T, because one more result that is given is the current I. So you can get current I by differentiating this charge Q. So differentiate equation number 1 with respect to T. So differentiate equation number 1 with respect to T. So derivative of Q with respect to T will be dQ by dt is equals to. So I have to use U into V form, product rule. So product rule has to be used over here. So U as it is differentiation of V, right? And V as it is differentiation of U. So let us use the product rule there. So if I try to use the product rule, we'll be getting 1 minus R by 2L times of T as it is. Now differentiate that value. You have C1 the constant as it is. Differentiation of cos of PT will be minus P times of sine of PT plus C2 as it is. Differentiation of sine of PT will be P times of cos of PT. So it is U into V dash plus V into U dash plus. Now let us try to differentiate that. Derivative of 1, the constant will be 0, minus R by 2L into differentiation of T will be 1 into the second term C1 cos of PT plus C2 sine of PT will remain as it is. Next term that you have is minus E by PR as it is. Differentiation of cos of PT will be minus P sine of PT. Further, let us try to simplify this one. So dQ by dt will be nothing but the current I is equals to 1 minus R by 2L times of T into, it is minus PC1 into sine of PT plus PC2 into cos of PT, right? And this negative sign plus into minus will be minus R by 2L into, you have C1 cos of PT plus C2 sine of PT, and this minus of minus will become plus. So I'll write down plus. What you have, this P and P will cancel out, will be left out with E by R into sine of PT. So now here C1 value is already known. We need to find out the value of C2. For that I'll use one more condition that is given in the question. So let me take this as equation number 2. So what is given to us? Given initially the current is 0 when the time t is equals to 0. So if I put these two values back over here, I is 0, so 0 will be equals to 1 minus t value is 0, so this expression will become 0 times of, it is minus of PC1 into sine of 0 plus PC2 into cos of 0 minus, you have R by 2L into C1 cos of 0 plus C2, it is sine of 0. Then you have plus E by R into sine of 0. So wherever you have sine 0 will be 0. This sine 0 will be 0. So whereas cos 0 value will be 1. Cos 0 value will be 1. So let us try to simplify this one. So this will be equals to 0 is equals to, so this has become 0 and this is PC2. So you are left out with only PC2 over here. Here this is 1, so it is minus of RC1 by 2L. This term has become 0, this term has become 0. But we know the value of C1. So just plug in the value of C1. So I'll write PC2 to be equals to, send this negative value on the left hand side, it becomes positive. RC1 divided by 2 times of L. But the value of C1 is known. So R by 2L, and this P I'll try to cross multiply here. You'll left out with C2. So C1 value we know, its value is E by P times of R. You can see this R and R will cancel out. You will be left out with E divided by 2 times of L into P will be P square. So you got the value of C2. So substitute the values of C1 and C2 in I. I is given by equation number 2. So therefore we have the current I to be equals to. So you can just observe equation number 2 and substitute. So we have 1 minus R by 2L times of T into, it is minus P times of C1 value. So C1 value is E by P times of R into, it is sine of PT plus P times of C2. So C2 value will be E by 2L P square into cos of PT. Next you have minus R by 2L into C1. C1 value is E by P times of R into cos of PT plus C2 value is E by 2L P square into sine of PT plus E by R into sine of PT. Just try to expand this one. I is equals to, you multiply this 1 with this entire expression. You can see this P and P will cancel out over here. This 1P will cancel out with P square. Now you can multiply this 1 with this entire expression. You will be getting minus of E by R into sine of PT plus it is E by 2LP into cos of PT. Then multiply this minus R by 2L times of T with these two expressions. So this minus of minus will become plus. However, this one R and R will cancel out. You will be having E by 2L. E by 2L times of this T. So it is ET by 2L into, you have sine of PT. Again this minus into plus will become minus. So multiply, it is E into R, that is ER divided by, what you have over here, 2 into 2 will be 4, L into L will be L square into P times of, you have cos of PT. Then coming to this term, you multiply this with this term, R and R will cancel out, you have minus of E by 2L times of this P, E by 2LP into, you have cos of PT. Again multiply this one, plus into minus will be minus, you have E into R, that is ER divided by, so 2 times of 2 will be 4, L into L will be L square P square into, you have sine of PT. Then the last term will be plus E by R into sine of PT. This negative value and this positive value will cancel out. These two terms will cancel out. Next over here you have plus E by 2LP cos PT minus E by 2LP cos PT. So these two terms will cancel out. Since we know that R by L is small, R by L square is a very small value. Here also R by L square is a very small value. Therefore we will try to ignore those two terms. So since R by L is small, R by L square is ignored because it becomes still a smaller value. So if you try to ignore these two terms, so we will just be left out with I is equals to, you can see all these terms have been cancelled. You are left out with here ET by 2L into, you have sine of PT. So this has been ignored and this also has been ignored, and all the other terms have been cancelled out, and you have got the value of I to be equals to ET by 2L into sine of PT. If you try to see in the question, for small values of R by L, the current in the circuit is given by ET by 2L into sine of PT. So that is what we have got, I value to be equals to ET by 2L into sine PT. So which is the required solution. That's all I have for today. Thank you.